Polaris. Is the North Star on the brink of disappearing forever? It's accelerating faster than the fabric of space-time can withstand, and it might just rip. I can't help but feel uneasy. Our night sky is changing fast, and in a few decades, or possibly even sooner, it could become completely unrecognizable. Astronomers around the world are sounding the alarm. Experts like deGrasse Tyson have recently confirmed concerns about the potential explosion of Polaris. And the story behind it is far more unsettling than most realize. For centuries, Polaris, also known as a North Star, has been a fixed point in our sky, a reliable guide for explorers, sailors, and scientists alike. But that constancy may soon come to an end, forever altering how we navigate and measure the stars above. Let's dive into why this looming cosmic shift matters, and what it could mean for us all. A star that guided civilizations. Polaris has long held legendary status, shining steadily from its position near the celestial North Pole, almost directly above Earth's geographic North Pole. Located in the Ursa Minor constellation, it appears motionless in the night sky, earning its reputation as a celestial anchor. But Polaris is more than a lone light. It's part of a complex triple star system, with Polaris A and B forming a binary pair, and Polaris B orbiting them from a distance. The gravitational dance between them affects their brightness, orbits, and stability. If those interactions shift, the consequences can ripple through the system, causing noticeable changes in the star's behavior. A troubling discovery. In September 2023, a groundbreaking study presented to the Royal Astronomical Society cast serious doubt on Polaris's future. The paper suggested that the North Star could be nearing the end of its life, possibly on the verge of disappearing from our sky permanently. Here's the twist. Polaris is approximately 323 light-years away, meaning the light we see today left the star over 300 years ago. If Polaris exploded tomorrow, we wouldn't witness the event until well into the future. In fact, it may have already exploded, and we're simply waiting for the light to reach us. A legacy in navigation and science. Throughout history, Polaris has been much more than a celestial landmark. Ancient navigators used it to cross oceans. Cultures revere it as a symbol of steadfastness and direction. Scientists relied on its stable brightness to study stellar motion and calibrate astronomical instruments. Notably, Polaris is also a Cepheid variable star, a type of star whose pulsations are predictable and have helped measure cosmic distances. But lately, Polaris has broken that pattern. Something has changed. Polaris's once consistent pulsations have grown erratic. It no longer dims and brightens in its usual cycles. Astronomers have noted that its pulsation period is increasing by 4 to 5 seconds each year, a small change on the surface, but a major red flag in stellar physics. Some experts believe these fluctuations stem from internal gravitational interactions. Others are more alarmed, warning that Polaris might be entering the final phases of its life. Its behavior eerily mirrors that of Betelgeuse, the red supergiant in Orion that has also shown signs of instability. While NASA has monitored Betelgeuse closely, Polaris hasn't yet received the same level of public attention, though its signs may be equally urgent. Will Polaris go supernova? To be clear, Polaris is unlikely to end in a dramatic supernova explosion like more massive stars do. While it has the size and brightness of a supergiant, its mass doesn't quite meet the threshold required for that violent finale. Instead, when it exhausts its nuclear fuel, Polaris will likely shed its outer layers and transition into a white dwarf, a dense, Earth-sized remnant that fades from visible sight. So while we may lose Polaris as we know it, it won't vanish in a fiery blast, but in a quiet, gradual transformation. What if it did explode? Hypothetically, if Polaris did go supernova, it could light up the sky, potentially outshining the moon and becoming one of the brightest objects for weeks or even months. It could shift our view of constellations like Ursa Minor, reshaping how we recognize the night sky. However, such an event would not pose any danger to Earth. Polaris is far enough away that even a large explosion wouldn't significantly impact our planet's environment or technology. Still, it would be a monumental event for astronomy. Observatories worldwide would train their instruments on the phenomenon. For stargazers and scientists, it would be a once-in-a-lifetime spectacle, comparing past stellar deaths. While Polaris may not explode, comparing its potential fate to other documented supernovae helps us understand what might follow. Events like SN 1054, which created the Crab Nebula, a cloud still glowing centuries later. SN 1987A, offering key insights into how elements are formed in massive stars. SN 2011F and SN 2024J, more recent examples that continue to inform stellar physics. These cosmic explosions shape nebulae, release cosmic rays, and enrich the universe with heavier elements, fueling the next generation of stars and planets. The final chapter for Polaris? Ultimately, Polaris's end will mark not destruction, but transformation. When it fades, we'll lose a guiding light, a star that has helped shape humanity's understanding of the cosmos. Whether we witness its last breath or simply notice its absence in a future sky, Polaris's legacy as our North Star will remain a beacon not just in space, but in our shared human story. The shock-wave acceleration from a supernova has profound implications for astrophysical processes and environments affected by cosmic radiation. To draw meaningful comparisons, scientists examine variations in mass composition and the velocity of ejected materials, specifically contrasting Polaris's anticipated eruption with previously documented supernova events. This involves analyzing light curves, spectral data, and remnants from past explosions, then extrapolating expected traits for Polaris. One key area of investigation is whether Polaris's explosion could result in the formation of nebula or unique elemental distributions, which would deepen our understanding of its potential impact. Another crucial focus is the pulsational variability observed in stars near the end of their life cycles, like Polaris, and comparing these patterns to those seen in supernovae or their precursors. Such variability may signal internal instabilities or foretell impending collapse, offering vital clues to the processes that lead to stellar explosions. Despite ongoing scrutiny, Polaris continues to exhibit puzzling irregularities. Deciphering the causes of its unpredictable behavior is essential for advancing our grasp of stellar evolution. Understanding these irregular pulsations requires interdisciplinary collaboration and the development of sophisticated models and observational tools. The potential disappearance of Polaris as a navigational and observational reference point in the night sky poses serious challenges. Ground-based telescopes and measurement systems would need recalibration, possibly affecting the accuracy of astronomical data. Moreover, Polaris's absence could disrupt navigation methods and cultural traditions rooted in celestial reference points, highlighting the broader significance of this cosmic phenomenon. The enigma surrounding Polaris calls for intensified research efforts. Astronomers must unravel its erratic behavior and provide insights that enrich our knowledge of stellar dynamics. The fate of Polaris remains uncertain, and only time will reveal its ultimate trajectory. Yet, our pursuit of answers amid the vast unknown exemplifies humanity's enduring fascination with the cosmos. The potential demise of Polaris also raises broader questions about the future of other stars. As astronomers continue to monitor the skies, they are reminded of the ever-changing nature of the universe. Stars like Polaris and Betelgeuse are just two of many undergoing dramatic transformations that illuminate the life cycles of massive stars. Numerous stars currently in similar evolutionary stages exhibit strange behaviors, such as fluctuating brightness and erratic pulsations, that may indicate they are nearing the end of their lives. These stars serve as natural laboratories for scientists studying the mechanics of stellar death and the explosive phenomena that often follow. In addition to isolated stars, researchers also study star clusters, where many stars evolve together under similar environmental conditions. Observing interactions within these clusters helps illuminate the gravitational and material forces shaping stellar life cycles. These environments may even lead to mass transfer between stars, significantly altering their development paths. Finally, the study of supernovae and the remnants they leave behind continues to provide invaluable data about the cosmos. Each massive stellar explosion adds to our collective understanding of the universe's structure, evolution, and the complex processes that govern the life and death of stars. Supernovae release immense amount of matter into space, enriching the interstellar medium with heavy elements. These materials become the building blocks for the formation of new stars and planets, demonstrating the deep interconnectedness of the universe. The remnants of such stellar explosions often manifest as nebulae, vibrant clouds of gas and dust that serve as stellar nurseries, where new stars are born. By studying these events, astronomers can piece together the grand cosmic narrative of birth, death, and rebirth among celestial bodies. The impact of a supernova extends far beyond its immediate surroundings. These explosions can influence star formation rates in neighboring regions, thereby affecting the development of entire galaxies. The shock wave generated by a supernova can compress nearby gas clouds, triggering the formation of new stars. In this way, the life cycle of a single star can ripple across the cosmos, helping to shape galactic evolution over billions of years. With advancements in technology, astronomers are now better equipped than ever to observe and analyze these cosmic phenomena. Space telescopes and ground-based observatories use sophisticated instruments to capture high-resolution images and spectra of distant stars. This data supports the development of complex models that simulate stellar evolution and predict the behavior of stars like Polaris. Moreover, machine learning and artificial intelligence are playing a growing role in this field, enabling researchers to process vast datasets more efficiently and uncover patterns that were once hidden. Beyond the physical science, the cultural significance of astronomical events remains profound. Throughout history, celestial phenomena have inspired myths, guided explorers, and shaped human worldviews. The North Star, for instance, has long symbolized direction and hope across generations. As our understanding of the universe deepens, so does our appreciation for how these cosmic events influence not only the fabric of space, but also the human experience.